Hey guys, welcome back to the channel. I have another ECM, this time working in a 1995 F-250 with a 7.5 liters ECM or PCM. This was sent to me by Amboy Transmissions in New York. Actually, I was referred by Corey from S&A Auto. So I'm going to show his YouTube channel. He's a YouTuber. He's a very good friend of mine. And he's, referred to me, this customer. So let me just show you his YouTube channel. If you have not visited his YouTube, please do. He's a great guy. He does a lot of diagnostics in New York. He's a very smart person and a very good person as well. So I like to deal with people like him that is down to earth. Like we all mechanics are. Sometimes we're a little, I don't know, a little pushy, but we're good people. And Corey is an excellent person. I met him and his wife, and we have gone into training multiple times. All right, so since I'm here, if you have any computers, instrument cluster from automotive or marine, look for Mike Salazar Diagnostics, and that's how my name is spelled, M-A-I-C, and it sounds as Mike.com. And here you can click on that white box that will download a Word document for you to fill. And that has all my address, telephone, and email. Everything is in there. Or if you want to email me, just go over to the black box that says click here to email us. Or the blue box on the right side that says let's chat. If you click on the chat, please enter your telephone number or email so I can call you or contact you, right? You can scroll down. This is a full website. I'm not going to make it too long. So if you want to go and visit the website, just again, look for MikeSalazarDiagnostics.com. All right, so I have the computer ready to go, connected here. As you see, I have, this is an original harness from Ford. I had from OTC, the complete box. I actually remove it from the case and I attach it to my desktop. I can remove it. It's only 2 bolts in here, but it's pretty easy because in here I got, it's a 60-pin computer. So in here I can put, like I have right now, the coolant temperature sensor, and I can check the the firewall reference, which I'm not sure if you guys can see it in there. And I should have put that in there. So give me 1 second. Right now I got the multimeter in there, which I will add when we're looking into the data and everything that I'm going to show you for the computer. So the way this computer came here, and I was actually a little surprised because their concern is shifting, but I couldn't even talk to the computer. The firewall reference wasn't even there. It was only like 3.9 volts. And I think I had all the information for that. So yes, this is the setup that I have ready. I even have a distributor that I can connect into here and run when it's necessary. But I don't think this is the case. This computer was, again, completely dead, no communication, and I'm going to show you that in a bit. Again, going back to here, we can see that this is the cable from the OTC. This is the OTC. Let me see if I have the part number. I have the box somewhere here, right here. We get back to this capture. So it's the OTC 3225. They're still for sale online. I was lucky enough to find this one in a brand new shape. I have another one. It's a little bit different because Ford has multiple modules. They had built, like OTC built this for Ford. Very specific at that time, in 1995, right? So they have connectors that you can connect over to the distributor, to the injectors, and so on, and use the breakout box to start doing your test, which that's what the dealer tech should have done, or maybe did at that time, because I am actually more lean to believe that the technicians before and the dealer, they spend more time in the dealer itself trying to correct the issues on the car as what they do now. If it's not correctable, new part, new motor, new transmission, done. All right, but let's go back into this repair. All right, so just to show you what I have, I have actually that in here. Let me put them into full screen. These are the pictures and everything as I normally do with all the repairs and tests that I do for the vehicles. And I'm going to show you the wiring diagrams in a second. So just to show you, when I first got the computer, this is what I got from the firewall reference. 3.92 volts. So that is definitely not correct. Hopefully they don't mind. They got the phone number. It's a shop, so I don't think they mind having the phone number. I will definitely talk to them first to make sure that they're okay. But I mean, it's a shop. And it's a good shop. the reason I say that is because they got a very good diagnostics, and that's what the computer's in here. All right, so this is me again showing the connection. Oh yeah, the serial number of part numbers in there, 3225 from OTC. I didn't see that when I was trying to show you that. But you can see this is very nice. It uses a little weird because it's a 2mm adapter instead of the 4mm, but I guess they did that to make it smaller, so less footprint. And there is some markings in here. There is a switch in here that I can go over to distributor or compute it. So that's for the distributor test. Again, like I said in here, I did a manual selection. Obviously, it's a 1995, so this is OBD1. And no communication. This is the way the computer got to me. It looks like somebody sold this computer and they sandblasted the computer. They did replace some of the capacitors, but obviously that didn't take care of the problem. And then they just send it back and like it's ready. And they said, as far as if I remember correctly, these transmissions, they said that they had tried already 5 computers and they cannot make the car run because it's junk and junk and junk. Because they have not get a good computer. So it's like finally, it's like Mike Corey recommended you very well. So hopefully you can help us. All right, so I started, going on the back and cleaning areas because it has like, I don't know what kind of sandblasting they use in here, but it kind of like it attaches to all the code of the computer. All right, so that's, again, this is just me getting more information. This is for the EPC system, which I'm going to show you in a second too. I also did this for myself. So this is the connector that will the diagnostic connector on this car, and you can read pits and faults and everything. But I don't have the vehicle here, so I need to understand what pin is 1 is, 2, 3, 4, and 5, and I number like that because on the diagnostic connector that I have behind me, right here, hopefully you guys can see right here, I have the BCI for the Snap-on SUS, which is the one I'm using now, and I also have the OBD connector, which has a power supply. But it's very important to read the data because it also needs a ground from the car in order to provide pin 4 sensor ground for the diagnostic connector. And pin 5 is not, like I name it in here, 1, 2, 3, 4, 5. That's the same numbers I got it from a Snap-on, not on the original car. They would not have that number. And you don't need it because you will just plug it in, right? But I did this for myself and I named the pins so I know pin 1 in this connector will go to pin 9 on the ECM and so on, as you can read in here. All right, what else I want to show you? Yeah, well, let me just show you some of the damaged areas. Let me just see what else. 1 second. Before we go over to the pinouts. All right, so I took pictures. I removed the capacitors and I cleaned as much as I could because, I mean, they left it realistically, I don't know how they were expecting to have anything working the way they left in here. You can see a little bit in here on this other capacitor corrosion. I mean, yes, that's the labor you are getting because they don't charge too much, or I don't know exactly how much they charge, but they don't do really good work. This is again another repair, and believe me, this was like, I mean, they left all the assets from the hydrolytic capacitor, the leak in there. I took my time to clean this really well, and I'll show you in a second. So this is again the third part, which wasn't so bad. This is at least it looks like this capacitor didn't explode or leak in there. So let me just show you now area 2, area 1 clean. This is my work, and I put mask protection after my repairs because then you know what is broken and what is not. Now that I clean in here, I can definitely see that we're missing a piece in here, right? Oh, you guys are not even seeing it. I'm so sorry, guys. I keep talking and talking, and I don't think I have shown you much. So let me go back to this part. This is me clean, just removing some of the damage, some of the hydrolytic acids. You can still see the fluid that I'm using in here. That's the second area, which you can see. I mean, and this was, I mean, completely all the hydrolytic acid and burn mark and everything was left in there. They just do as quick as possible and see you. That's how I call always. And that's the third part that I was saying that it wasn't so bad. I just clean it up and get it ready. But yeah, this is just the first stage of me cleaning. Then the second stage of me cleaning, that is very different, right? So I go to metals because otherwise you're going to be leaving acid in there that will corrode and it will damage the computer later on. And obviously now I can definitely see first right here where I'm moving that. Hopefully you can see that white hand in there. This section right here is completely gone. Not only that, right here in the big area, that is the ground. That center part, which is where the capacitor is going to be welded, it's not even making contact. It might make contact and it does stop making the contact. You see, because if you don't clean this well, then you're never going to find out that. And this is, I mean, I'm just showing you the tip of the iceberg, let's say, on the repair, because I don't want to make the video too long. This is, again, me cleaning, soldering, putting extra grounds because it's nothing else you can do. You need to create jumpers. And that is the third part that wasn't so bad. All right, so what else we have here? And that's it. I mean, I found very good information on Identifix. Very, very good. This is still a good quality, spam, a good quality diagram. Because some of the diagrams, come on, there are some diagrams that you get and download from Identifix and or old data that you cannot even read the numbers. In here, that's what I download this one. It is in good quality. It's understandable. I mean, they're from 1995, right? So there's a copy of a copy and a copy, but this one is a good one. So I follow all in here, but the nice thing about this diagram that I found is not only it has, a lot of pages, which is, very important. It has everything that I need for the transmission controls, and everything is in good quality, but it has also the pinouts of the connector. If I scroll down, let me just go a little faster. This is the computer pinouts. I'm not sure why that line is in there. I've been trying to get rid of, but we're going to have to live for now with that. But yeah, we have the connector in here and all the pins. I'm going to make this a little smaller. I'm going to leave it in the computer so you guys can read it. But I also want to show you something else how I know which wires were on where on the connector for the Diagnostics, since I don't have the card in here. And this is nicely done by Ford. I'm just going to scroll down because the connector of the Diagnostics is also here. So nicely done by Ford engineers at that time. They put in here, okay, this 359, 926. I'm going to get a box in here so you guys can see where I am, as I normally do, because the pointer doesn't work in here. So right here, I got a 359. The next pin bound, it says 926. This one is a 915, 914, and 658. So if I follow this, what is 359? Okay, well, we had a lot of numbers in here, right? So look at right here at the top, 46, 359, sensor signal return. That is a sensor ground. So that is very important. What is 926? Well, let's find out if we find a 926 in here. We got a 929, which, yeah, we don't have that one in there. So let's just scroll up to the next page. 926, right here. Pin 22, 926 says fuel pump enable output. Okay, well, that would be one. It's enabled. So you have to follow the diagrams and see if that goes over to a relay or it goes directly to the fuel pump. Because it will be two different things, right? I don't think the computer in this case on that year model was directly controlling the computer. I'm sorry, the fuel pump. It was just controlling the fuel pump relay. Not really correctly spelled in here, let's say, but it's good enough for what I'm looking for, right? So let's look for the rest of the things. So we got a 914. So 914, yeah, we already got the 915. No, 915, we don't. But let's say, what I want to show you is where I got the numbers from. So yes, if you scroll up, you will find all those signals in here. We got the 914 in here, which says BIP data link connector, 915 BIP data link connector. So pin 9 and pin 28. That is the data bus. That's how this scanner talks to the computer, right? So pretty easy if you take your time to understand how it works. As far as the fuel pump, if we go over and look for pin 22, which if we scroll up, let's look for the, did I see something about the fuel pump in here? Inertia, fuel tank. So this says page 24.1, inertia fuel. Oh, that's the shut off. So this is part of the fuel pump, but it's nothing in the relay. But it says almost that it's almost in page 1. I will be leaning to believe that we might be there. So yes, okay, perfect. So now we have the fuel pump relay in here, right? So we have a constant power on one side of the relay and then terminal 87, which is going to supply power to the computer and then to something else, or to the inertial fuel pump switch, which is, a kill switch, right? But so the computer, as I said, is not in control of the fuel pump. This will be just a confirmation when this relay closes that the power to that fuel pump is being supplied. But pin 22, the one we were looking for, which is here, right there, is one of the pins of that relay. So it says on the 12, the upper part is a 12 volt. So this is a 12 volt to the PCM relay. And then this is what? A ground side activation. So I can put then a test light and check that if the fuel pump is coming on or off. So you see, this is how I do it, a bench test. And this is how you do it on the car. Read the diagrams, understand how the circuit works, and then you can, perform your test. If I have no fuel pump, I will go over to that fuel pump relay, take a test light to battery positive, turn the ignition on, and see if the computer is commanding that relay to close. If I have checked and I have the 12 volts on this side, all right, so that relay means it's closing. But I don't have this ground. Well, then now I need to check the computers. I need to check the wire from that relay to the computer, and then, or the computer is bad, right? So again, just trying to show you a little more of wire diagrams and how to follow it on these domestic vehicles, especially Ford. Ford has actually done it very well, a lot better with the new ones, because most of the diagrams on Ford right now are colored and they have hyperlinks. Nicely done by Bosch, because Bosch, this is from Identifix, but if you go to Identifix, Mitchell, and all that, all these color wire diagrams are done by Bosch, and they buy the rights to use it. That's it. But yeah, at least it's nice to have a color wire diagram that I can confirm how is everything interconnected in the car. And I save all this because it's a lot faster than going over to those multiple pages. But I always will confirm that everything is connected properly, especially when I don't have the car. All right, guys, so this is all the connections. I am now going to take you over to the scanner, which I have in here. So let me just, since I am in here, I am right now on the coolant temperature sensor, and I am providing through my decade box in here resistance. So I'm going to change the resistance, and we're going to see a change in temperature. So we went from 89 degrees, or from, let me just rephrase that, 118 degrees to 89. I can go higher. We got now 230 degrees. Now we have 118 degrees. And now we have 89 degrees. So remember, this is the SUS Plus. The SUS Plus is not directly connected to the computer. I am connected to a VCI. There's a wireless VCI, and that is connected to that connector that we talked about just before, the diagnostic connector. But we can see that I'm talking and everything is good. I can exit here. Actually, let me go over to data displayed again, because I want to show you now, because, well, I have also the meter, which I have not put in the image, but we can see now 5 volts. I'm going to remove it because, yeah, you can see from that small image in there. So you can see that that is actually live data. I'm going to just remove it from that breakup box. That's a wire that you can see now hanging in there. And I think it was pin 26, if I remember properly. Yes. We can see we got the 5 volt reference. Before it was 3.9, and it was going down to 3.3 with all the problem this computer was having in there. We can also see, if I see this pits in here, we got a voltage reference. We got there was another one in here. Manifold, I don't know, man lab position. It says 5, but I'm not sure if it has voltage or not, because it doesn't say. We got the battery voltage in here too, which I can change with my power supply. I can go up a volt, and then down a bolt. And I'm going to show you one thing that this is very important because I am changing the values. And you're going to say, well, but nothing is happening on the computer. This is OBD1. And this is where having all those bits selected can really throw you off if you're a new technician and you're working in all these cars, right? The old vehicles. You'll say, well, that the scanner is not reading, something is not right. And I did that on purpose. Let me take that meter because we don't need the meter no more in there. It's just in the way. Now, if I do a custom selection, I'm going to deselect all, and I'm going to do the same selection. So let's go over to battery voltage and voltage reference, and I'm going to graph those two. First, I want you to see the update rate is a lot faster, and I'm going to now change the voltage. Let's change it. No. Yeah, now I'm changing it. I am, guys. You see, this is where you have too many tools. I am changing my voltage supply and I'm connected to this one. And this one, I cannot change the voltage. So this is a funny thing that, yep, I'm like, I'm changing. Why is it not changing? Well, the reason it's not changing is because I'm not using that. And I can prove you because hopefully you see that when I turn them off, the one I'm using is this one. So that has nothing to do with that adjustable power supply. I'm using this one for this test. So, yep, disregard that. So that's probably why I went and select the coolant temperature sensor just to show you. And let me go back to the data display. Because I want to show you that what I was saying about that coolant temperature. Now let me see where the coolant temperature, I think it's on the right side. Yes. So I'm just going to put the coolant temperature in here at the bottom, or sorry, at the top. And I'm going to change those values. Well, actually, it is changing. We can see that graph. And this is what I love to have those graphs from Snap-on because it's something you can see immediately with, even to the distance. So, yeah, the computer is actually, the rate of exchanging the data is good. All right, so I'm going to exit here. Give me 1 second. All right, guys, off the, behind the scenes, they said, I've been doing some more homework. I also noticed because I was not able to actually extract the full codes, and I'm like, I'm definitely missing something. So I want to show you what I found because I now did a little correction on the cables that I have in here. So let me take that away. Okay, so before this part in here where it says C99 separate wire to pin 48 on the ECM. So this connector, the one we're seeing right now, is C198. That is this one with 6 wires. Next to that one on the 4 is another connector. It's just a 1 wire that is hanging usually there. It's called C199. And that is a purple wire that goes connected to pin 48 on the ECM. If that is not connected, you will not be able to read to read codes and so on. And I have now that connected. So if we look into the wire diagrams, which I missed that because, obviously I don't have in car here. We have that right here. Pin 48, we got pin 28 and pin 9, right? We discussed those before. But then we have pin 48, which it says, you see right here, connector 199. Yeah, it's pretty easy when you have the car, but not when you don't have the car, especially in this oldest one, right? But then we have the C198. So, and I went in on the locations that are right next to each other, and I saw that in here because I have that 1 wire that I was missing in there. If you guys, let me show you here. Now look in here. This is the mill. The check engine light is now blinking. Why is blinking? Because I'm now in diagnosis mode. Let me show you the scanner now, reading full codes. And also by doing this, now I prove that now the EPC, the pressure for the electronic pressure control for the transmission is actually working perfectly. All right, so let me get you to the view, which is right here. So we have now, I'm reading code. So it says key on, blah, 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 transmission, oil temperature, not connected. Bottom map, throttle position, intake, EGR, manual lever position, not in park. Air management, canister, fuel pump, EGR, shift solenoid 1 and 2, but not the EPC. Why is the EPC not on? Because I am now supplying in here Let me move you here. I put a coil in here. It's an IAC valve that is almost the same resistance as the EPC solenoid, and the computer is liking it because it's not giving me any faults. And when I read the codes, if I get out of here, I'm going to unplug this wire that I plug here. Actually, let me do it from here, from pin 48 on my decade box, right? If I go now to here on the same area that we were on the scanner, we have the first one says key on, engine off. That means those letters key O E O is key on, engine off. The key O E R is engine running. So I cannot make the engine run. Well, I can, but I'm not going to do that. So I'm going to do the self test. This is going to take like 60 seconds. I got to take the ignition off, follow the prompts, key on, and no start a car. If I do this, it's just going to stay there for like 60 seconds and nothing is going to happen. And I want you to see this. The check engine light is steady on. Why is it steady on? Because I have this wire unplugged. This is like a 5-volt signal the computer sends in order for it to activate that reading of the fault codes. And you don't need a code reader. They sell a code reader that you can connect directly in there. With a snap-on, I don't need it. It does read the fault codes. But I want to prove this in here. So you guys probably not going to be able to hear, but when I do this self-test, the EPC should run. Why it's not running, or why it didn't run? Because I don't have this wire connected. But when I do the self-test, it's going to check those outputs, and if the output is not connected, it will give me that fault code. And I'm just going to leave it. It's about to time out. It's a little over 60 seconds, and then it times out. So I want you to see that. Come on. Sometimes it takes a little longer than expected. But I know it takes like a little over one minute. It's just a computer trying to read the fault codes in the scanner itself too, right? So if you ever have a scanner that is not reading fault codes, but you can communicate to the computer and read the data pits, check that wire, make sure it's not broken. And if you need to run a new wire to pin 48 in the computer, that will solve that situation. So this is a lot of stuff that we are gathering. You know, I like this, you see, and just time out, no codes. So I'm going to plug pin 48. I'm going to turn the ignition off, and I'm going to unplug that EPC, which I have here. This is the EPC valve. Because remember, we were reading codes before, and that fault code for the EPC were not there. So let's see if we can set that fault code. Right now, I got the cable connected to that extra wire on the DLC. I turn the ignition on. And let's read fault codes. Oh, that's not the one I want. Come on. I can abort it on the next one because I clicked the wrong one. We have to do this one. So ignition off, continue. And then before we can continue, turn the ignition on and then hit that. Now it's going to take less time to read fault codes. It's going to try to activate that valve. And I can see now blinking. The check engine light just went off. And now we have the faults. Now it's going to start blinking and blinking and blinking because you can read the check engine light blinking and that will give you codes too. And now let's see if we have any EPC fault. Continuous code, analyst, 622, 621. No, it looked like it didn't set the fault. Transmission oil temperature. So let's do it one more time. Warning, self-test output is energized. If any other sets, warning, the self-test output is energized. If any other self-test has been run, turn the key off. Okay, so we need to turn the key off. You see, it's knowing that it's on self-test. Turn the key off, wait, then turn the key on. Okay, so now we are out of the self-test part. We're going to click that key on, engine off, and let's try one more time. I'm just trying to see if I can get that fault to happen. Manual lever. 621. Yeah, it's not reading that full code for some reason. Because, it's like, I would really like to have that fold here, because when I'm going to get out of here, turn the key off, and I'm going to plug this wire back into the pin 38, which is for the EPC. I'm going to go ignition back on, key on, engine off, self-test. All right, so turn the ignition off. It's asking me to do that. Continue, key on, engine off. When I do that, I can hear in the solenoid being activated. So I can definitely know that that circuit is operational. So this is because this is part of what they were having as a problem. And that's the reason I'm trying to do this. But I know this computer is now fully functional. Everything is working good. So onboard transmission in New York. This is a test for your computer that I'm actually showing a lot more that you can do in the car. This is for anyone that has a Ford that wants to run this test. You can do the self-test and you can then check for that activation on the EPC solenoid, because the same thing that I'm doing in here, right? On the self-test, you can connect an oscilloscope and see if the EPC is being commanded on and off at that moment. And I can connect an oscilloscope and I can show you that signal is really not necessary because I can hear it. I know it's working 100%. So this is where I don't want to extend an already probably long video unnecessarily. But I know for sure that it's working. Everything is now fully functional on this computer. So guys, I hope that you like the content and you see how much more in depth I go. It's not just because I want to, waste my time. No, it's because I'm trying to share what I know. I am very passionate about mechanics and electronics, and I like to pass this along to new technicians, to vehicle owners, especially on these old cars. There is a lack of information that you cannot find online that otherwise I'm actually now sharing, so you can see wire diagrams. If you have one of these cars and you need wire diagrams and stuff like that, I will be more than happy to help you and send it, no charge. I am just really looking to help people around the world, especially here in the United States. And I hope that you all like that. And please share my videos, hit that like button. That really helps my channel and my small business, because a lot of my clientele comes from all these videos. And I really appreciate, and I bless you all that watch my videos and trust in my Salazar Diagnostics. So thank you so much. All right. I will see you next time. Bye-bye.